Today, I'm here to explain about this question. Evaluate the following limits. Let's start with number 1. Limit e to the power of x as x approaches infinity. This might look a little bit complicated, but if you can draw the graph of e to the power of x, it's going to be really simple. So let me draw the graph of y equal e to the power of x. You know the value of e? It's a little bit complicated, but it's almost 2.1 something. So when you plug in 0 into x, it's going to be e to the power of 0, which is 1. Something to the power of 0 is going to be always 1. If you didn't know, you need to know that. And e to the power of 1, so if you plug in 1, it's going to be 2.7 something. And if you plug in 2, it's 2.7 squared, which is going to be really bigger. So as x increases, the value of e to the power of x increases as well, like exponentially, like this. So graph is going to be like that. So the question is, as x approaches infinity, so if the x is going to be this side, the value is going to be like that, which is infinity. So the answer is infinity. Okay. So for the next question, this one, 0.9 to the power of x. This one is almost similar. Let me just draw the graph first. 0.9 to the power of 0. Like I said, something to the power of 0 is always 1. And next one, it's going to be 0.9, like this. And 0.9 squared, it's going to be 0.81. So as x increases, the value of y is going to be slightly decreasing, like this. On the other hand, 0.9 to the power of negative 1, which is 1 over 0.9, of course, denominator is smaller than numerator, so which is going to be bigger than 1. So as x goes negative, the value of y is going to be increasing as well. So the answer is, as x approaches infinity, the value is getting close to 0. It doesn't go to negative. You know why? Because even though there are, like, for example, 200, there's no way to get it to become negative, because it's 0.9 times something. Positive times positive is always positive. If there's negative, it can get negative, but it cannot be negative. So the answer is like this. Okay. Now, you might have noticed it. If this value is going to be really important, let me put this one as a. If a is bigger than 1, the graph, like this graph, is going to be like this. But on the other hand, if this value is smaller than 1, the graph is going to be, I'm sorry, it's so ugly, like this. Yeah. So when you want to find the limit of some exponential functions, this value, this is called base, but the value of base is really important. That's all.